Hello and welcome to part 3 of this, I don't really know what to call this amp. We've been calling it the Christmas amp, but we can't call it that forever, can we? I actually call the other one the P-valve amp because of the tubes, PL84, PCF80 and so on. So I think we can call this, for the time being, we'll call this P-valve amp 2. So you can see I've started doing some of the components in there, and I've got this cathode wired up on the first stage on the triode of the PSP on the triode of the PCF80. Can't get the words out today. So we're just laying out the components on this board, getting all this wired up. We've got the other screen resistor on now. We'd only got one on yesterday. We also need to be careful because Pink is lurking around as usual, and it always seems to be when I start filming. I think she's kind of associated that now with getting some treats out of me. It's very crafty as Pink. Anyway, back to the amp. So 3.3k resistor for the cathode on the triode of the PCF80, 25 microfarad bypass cap, 100k plate resistor. Now these are in the right place, but I'm still looking at how we're going to place this lot out, because there's 100k there for the slope. We've got a 200 picofarad. I've not got a 250, so we're going to try this 200 in again. We can always change it. We've got 0.1 for the base, 0.47 47 nanofarad, and another one the same, 0.047. What did I say? Pink was lurking. She's already lurked into our camera almost. So yeah, that's the bypass, the coupling cap for the first stage. Yes, Pink. So we've got some screened cable. So we've got the input socket here, and we've got to run that screen cable down onto the tube base there, and we're going to use a 33k, and I've got that there, a 33k grid stopper on there. We're going to have a 1 meg grid leak on the socket. So usual deal really, more or less almost same as what's going on with the Pro Reverb first stage, except of course we've got 3.3k resistor on here. You really don't want to go above that with these, below that with these PCF80s, or they just feed back. But with that on, it's fine, and I know that's fine because that's what's on the prototype that I built, and I've gigged that for nearly 3 years. I actually looked, believe it or not, it's nearly 3 years I've been gigging that. Oh, it's certainly when I built it, and I more or less used it straight away. So yes, and it's pushing towards 1,000 hours, nearly 900 hours now. So we're getting, yeah, I've had some good use out of that one. Yes, Pink. And what are you doing here, need we ask? So that's where we are at the moment with this. I'm just going to carry on building this as we go, and cleaning the flux off as we go. And you know, you often hear people say, you know, that boutique amps are expensive, and believe me, you know, when you're building these amps, you can see why they're expensive. You know, the work that's involved in making this neat, and some of the guys that do this, they're far neater than I am. The work that goes into it, you know, stop it, Pink, that's naughty. Cleaning the flux off, you know, off every turret, and making sure every little connection's perfect, the leads are tidy, make sure the board's clean, and there's a lot of work involved to do it right, as I'm finding out. Thank you, Pink, you've just knocked the camera out of focus. As I'm finding out. Right, I'm going to give Pink some treats, or otherwise I won't get rid of her. And I'm afraid we've gone down slightly in quality. We've now got the Tesco tasty treats here, And you can see, although she's rubbing those, she's not quite as keen to run off with those, because they're what we call, they're not grade A, they're what we call grade B. So yes, but she'll eat them nonetheless. Right, so we've populated the board a little, well, more than a little really. So we've got, that's got something out of there. As you can see from the camera being swaged, that we've got pink in here yet again, and yet again is trying to hijack me for food when I'm filming. She seems to know now when the camera's on, and hastily makes her way onto the bench. Stop it. So let's just have a look at how we've done this then, because it's when you're doing these, it's just laying them out and properly. And as I haven't done that many of them, I've done one or two of these turret boards, but not a huge amount. So we've got the cathode resistor here. That's pretty straightforward. That's for the PCF80 triode there. And we've got the bypass cap. That's 25 microfarad. Oh, it's 22 microfarad to be exact. I'm quoted from the schematic there. Then we've got a 100k plate resistor here, which is for the triode of the PCF80. These components here are for the tone stack, and this is the slope resistor in the tone stack. So if we go to the schematic, so we can look on either of these tone stacks really, it doesn't matter, they're both the same. So if we look, we're coming out of this plate resistor here. We've got the 250 picofarad there. There's the slope resistor. We've got a 0.1, and then we've got a 0.047 there. We're having a mid control, so we won't have that 6800 in there. So if we go back, to the amp, there's the plate resistor coming out of the plate resistor. There's the 250 picofarad decoupling the DC. The DC goes through the slope resistor and then is decoupled by the 0.01, and then it goes through, the DC goes through again to the 0.047 and is decoupled to here, and then these will connect to the pots. So that's how that's done. That's the EQ, the tone stack. So when we've done all of that, it will then go into the volume from the treble control. So it'll come out of the treble into the volume, out of the volume, and then that will go into the grid of the pentode of the PCF80 here. This is the cathode resistor. Thank you, Pink. This is the cathode resistor for the PCF80 pentode 2.2K, and again 22 microfarad bypass cap. This is the plate resistor for the PCF80 pentode section, and it will be fed over here, and we haven't got those feeds in yet. That side of it will connect to the tube, and then the DC comes across here to the coupling cap and is decoupled here, and that will go on then to the phase inverter. These that we've got here, these components, so this 470 is the screen feed on the PCF80 pentode, so that's the screen feed. These components here are for the morph control, and I think that I may need another resistor, which may have to go on the pot. We'll need to check that. So these two components, this 0.1 actually here is the screen bypass cap, which goes from the screen to ground. And this is part of the morph control, this 470. This is to keep the DC off the morph control pot, so it's not scratchy when we're turning it, and we don't want DC on the pot anyway. So that's that. These components here are all part of the phase inverter. This resistor here is the feed from the screens, the drop-in resistor, to the next power node, which will power the phase inverter. So here's the phase inverter here. We've got 22k, we've got a 470 cathode resistor, 22k tail resistor. We've got the grid leaks going on here, on the going from the grids there. We've got a 47 to ground here, 47 ohms, and we've got a 0.1 here, and this puts the grid to ground on the other side of the phase inverter, because we only use one grid. We go in through the grid there, signal comes through the cathodes, out of the plate into there, and then we've got this arrangement of resistors here, and then this grid is not used, so we can't leave it floating, so it's connected to ground there technically. So although there's a 47 in front, that's as good as ground. It stops it, because otherwise it'll just buzz like a guitar lead being just plugged into an amp with no guitar, and just get that humming. So that's what what's going on there. And if that equates onto here, we just clip that back on. So let's just look at that then on the components. So there's the cathode resistor there, 470, and none of this is soldered up, by the way. Yeah. There's the tail resistor, 22k. There's the two grid leaks. There's the 0.1 that puts the second triode grid to ground. There's the 47 ohms, which is actually going to ground. And then we've got plate resistor 100k for one side of the triode, decoupling cap there, 47 nanofarad, that's what we're having on across this amp, 82k on the other triode, coupling cap there, 47 nanofarad, decoupling the DC. So that's roughly, you can see what's going on there, and that's all got to be soldered up. We've got some more drop-in resistors to go in and bits and bobs. These caps here are the bypass caps for the cathodes on the output tubes, and we're having separate cathode resistors on each tube. One of the reasons is that we don't know whether these tubes are matched, and obviously buying these tubes in matched sets is not easy, because generally they're used singularly in a TV, so you know they're not generally used for audio. Remember, we're pushing the boat out here, we're experimenting. That's what this is all about. These two caps are the cathode bypass caps, and they're 470 microfarad, and so I'm taking bits of some amps that I've worked on that I've liked the tone of over the last year or so I've been working. So the Black Stars Artisans have these 470s on, so I thought, and you get a nice rich lush tone with these, so I thought we'd try those. We can always change them if we don't like them, and this is the beauty of this turret board. It's quite easy just to take components in and out, not difficult. And then obviously we've got the cathode resistors to go in. Now, why are these both together here? And I may move them up another turret, because I put a cathode resistor in here, and then I put a bypass cap there, and it's getting all the heat from the resistor, and then that one will be getting the same. So I've put these together up here, and then I want to put the cathode resistors away from them so they're not getting a lot of heat. That's the general idea of that. we've got a few turrets left, but we've still got the grid leaks, remember, to go on for the output tubes, which on here are 220k on the AB 763 schematic. But as we're having a post face inverter master volume, they may have to change. And I think that's about where we are at the minute. That's just about where we've got to with it. We've wired up we've wired up the cathode on here. We've not soldered that end, we have on the tube, and we've wired up the plate on the PCF80 triode. And what I'm going to do now is, I had a day off yesterday. Today is Tuesday, the 30th of December. So yesterday I didn't work at all. I had a day off. Charge the batteries because I've been doing some late nights, in fact a lot of late nights, and we'll be doing a late night tonight, no doubt. It's dinner time now on a Tuesday, so what I'm going to do is start wiring this up now. All of what components I've got here, I'm going to try and wire them all up, so this tube all wired up, and then once we've done that, we'll know what space we've got left on here, and then I can divide the rest of this space up with these cathode bypass caps and the cathode resistors there, and get the master volume in, and then the rest of the dropping resistors. Also, we've got no negative feedback on this amp yet, and the negative feedback again is on the AB763 schematic. And again, if we look at the schematic here, you can see that we have, coming from the speaker, 820 ohms, and that is coming, if we track that down, that's coming from there. Not sure what the impedance of the speaker is for that, so we'll have to check that, because we've got 3 tap-ins, and obviously we've got to put that on the correct tap-in. I'd got it in the back of my mind that they're 8 ohms, but I don't know. I might be wrong on that, it might be 16. But anyway, there's only one tap-in on this transformer for the speaker, so we need to find the impedance of that. Probably most of you know, if you work on these, you know, if you live in the States, you're probably working on these amps a lot. I don't see many at all. So yes, we'll check that, and then we'll put that in. And if we look where that connects, it comes down here and connects to the 22k here. And let's put the lights back on again. So if we look, that is connecting to here, methinks, that me knows. Just check again just to see where it is connecting to. Yes indeed, so the negative feedback will connect here. Right, I'll get on to do a bit more, and then we'll come back and have another look. Right, so I've got quite a bit done today. Tuesday now, it is 11:05 at night, and I am going to knock off. So let's just go through what we've done. So first of all, we've got these tacked in here. These are the cathode resistors, and this 10k resistor is tacked in here as well. This is the drop-in resistor from first to second node. They're just tacked in because we may well need to swap those and adjust them. We've got the ground bus along there done. Now we've wired up the PCF80. So we've got 33k grid stopper, as we said. We've got the cathodes wired up here, and then we've got this 33k grid stopper. This is coming from the treble control. Sorry, it's coming from the volume. That's coming from the volume. So I've got a 33k on there for when the volume is fully open. We've wired up the tone stack. That's all wired up now, but the components just need to be soldered. They've been pushed through and they've been just soldered, but they need soldering. the components need soldering in and they need crowning. All of these need a crown on them. The morph control's connected up as well, so we're rolling with that. All the phase inverters wired up, so the PCC85 is wired up. We've got a 33k grid stopper going into the phase inverter from the pentode part of this tube. So we've done all of that, all done with screen cable. You can just flip that up, you can see all the screen cable there, so that's all been done with screen cable. We've got the negative feedback in. This is this blue wire here coming down into here. There's our 820 ohms. So we've got him in and he's on the 8 ohms tapping, and I've just soldered him to the 16. As soon as I said that, I thought, idiot. So I'll have to swap that over. It should be on the 8 ohm, not the 16. Duh. Plank moment. And that's about it really. We've got the cathodes wired up now on the two bases here. So the only thing needed on here now is the grids wiring up. So looking at what's left to do on this amp, we've got the grounds to put in on the preamp. We've got to solder all of these and crown them so they look nice. We've got this cap to connect up and this one, they're the 32s. We've got a drop-in resistor here, 2.2k. That's dropping from the phase inverter to the PCF80, and then we need one of those connecting to there. This 1.5k coming in here, the other 32 will be connected to there. So we've got that to do, and then we've got the master volume to do and the grid leak resistors, which is where the master volume will connect in, which will be these two here that we've got, three here, sorry. These turrets here, save those for that. Right, it's all put together. It's in the cradle and we're ready to go. The master volume's in. The only things that aren't connected yet are the cathode bypass capacitors on the output tubes, because we're going to be messing about with these bias resistors, so I didn't see the point in connecting those up. We can do that after. And there's no virtual center tap yet on this amp. This transformer we've got for the filaments doesn't have a center tap, so we're going to need a virtual center tap. We've not got that on yet. We'll be experimenting with that once we've got it running. An experiment is the word. So that basically this is what we're doing here. You know, this is an experiment. Yeah, we hope we get a really nice amp out of this, but we are experimenting with television tubes. So we may come into some problems. This may or may not work. It may work fantastically well. It may not work very well. I don't know. I mean, I've done this before with other tubes. I know the preamp tubes will work because I've used those in another amp and I've tested those extensively. Well, I've gigged them for 3 years. But it's these output tubes. Now, the other thing we're not sure of is whether we're going to be able to match the effective load resistance. We don't know what voltages we're going to get. I've got a rough idea. So now I need to find the tubes because I'm going to put the test tubes in, the second-hand tubes, rather than the new ones. So we're going to get those in. Well, it doesn't matter about the PCF80 because we've got millions of them. And that's not going to be an issue. It's the output tubes that'll be the problem. So I'm going to get the tubes in. I'm going to get the signal generator off the test bench, and we're going to plug this in. I'm going to bring it up on the bulbs rather steadily and see where we get with it. Right, we've got a bit of a side shot on there so we can see the meters. And so the meter in the middle is going to be monitoring the HT voltage. We'll put that on DC, and you can see, just about see the bulbs there. I've dropped the lights, so just got light on behind us so we can see pretty much what's happening. I'm going to manual focus with the camera, and we'll bring that down a little. There we go. So we are ready to roll. Current limiter is on, and we're going to fire up. You can see that bulb has lit, and we've got 49 volts. I have checked to make sure there's no shorts on this as well. So just going to let that voltage rise a little. So just a 15 watt bulb in there just to start us off. And that's all looking good. The bulb's got slightly dimmer. Right, let's double it. $158 and climbing. But no sound. So I'm not really expecting this to fire up first time. You know what my projects are like. Yep, so just take that out now. Put the 40 in. That's 55 watts, and you can see the bulbs are quite dim now. So that's looking good, which is telling us no shorts. We've got 160 volts going into it, so I would have thought we would be hearing something by now, but nothing. Well, can I hear something? No, I'm imagining it. I can hear something. Yeah, I can hear something, but it's not very loud, and I would expect it to be now. That volume's not working properly either, so, and I've got a bit more going in there than I normally do off the signal generator. We've got 0.4 of a volt, 400 millivolts. Oh yeah, I'd expect to have, so we have got a problem somewhere. I haven't got no shorts or anything, we just, right, let's swage it a bit more. There we go. I've got 95 watts in there now, and the 240 bulbs aren't even lit. You can hear it coming up now, but we have got issues. It's flat out now. Right, let's just see what bias voltage we've got. So that'll come up on this meter on the right, if you can see it. Got 12 volts and 10 on that one. Wow, 10.88, 11. So yeah, so that's not very well balanced, is it? 10.88, 11.9. So they're about a volt out. Just quiet. It's working. It's just quiet. I can hear it out the speaker, but it's just quiet. But my projects, you never usually work first time, so it's no surprise. Output tubes are warm. One is warmer than the other. What have I done wrong? Maybe something I've done wrong. Right, let's just see what's on the plates, shall we? See what's yep, 208. What's on the screen? $165. We've got a 10k resistor in there, by the way. And on the cathode, we've got 127. Sorry, 112.7. Sorry, on that tube. And on this tube, we've got 10.7. Something's not quite right there. and look at the bulbs. So something's causing a short. So better switch off. The bulbs have caught that, so it's no problem. There's something not right with that tube socket, strangely enough. I don't know what that could be. Have we been done up like a kipper? That's so if you 230 milliamps, 200 milliamps. So that tube doesn't. I think we'll just switch off and investigate that problem. What's going on? Actually going on there? I'm not quite sure what's going on there. There's something with this tube. Let's try another tube. We'll just put that to one side. Let's try another tube. And that's a 504. Right, got another tube in there now. So we'll see what happens with that. Well, that tube's absolutely fine. So it looks like I've got a problem with that other tube. What's wrong with that? But yeah, everything's looking right. Actually, if you look at the bulbs glowing now, and the current is 220 milliamps. So when I moved that tube and the bulbs flicked on there, it was because it was conducting. So I wonder if it's the pins on that. We'll have to have a look, see if the pins won't clean, or is the tube just faulty. We're running as to a fashion, but we've got very low signal. So all the tubes are warm. Actually, yep, that one's warming up. Now let's look at the bias, the bias voltage. Now, ten, 12, 12.8 and 10.10. So strange, don't know whether there's a discrepancy in those resistors. Yes, so I've got 217 volts now on the plate. That's not plate to cathode though, remember this amp's cathode biased. And what we got on the screens, we've got 168. We need to be around 250 to 275. 250 would be fine. So we're going to go up on the bulbs some more, and I'm going to go up to 180 watts. And you can see the voltage is coming up now, but the volume isn't. So we've got 279 of plate volts now. And we've got 206 on the screens. So that's all looking good at the minute. It's looking very good, despite our fault. 17.45 on there. And 16.8 on there now. So we now need to check the bias, because we don't want to be running these tubes over what they should be. So that will be the next job, is to just do a rough bias calculation and see where we are with these tubes. So we'll just use that 17.4. Now that's a 330 ohm resistor. And that's running at 52 milliamps, so we're over. So we need to increase those resistors, don't we? I thought they would be a bit low. And that's on the current limiter, remember. So they're swaging pretty, they are swaging. So we'll just shut down and I'll change those resistors and then we'll have a second look. I think we need to go up considerably there at 330. So probably need something around 560 maybe in there. Right, I've just changed those resistors now. I've got some 510s in there. Although they measure 500. Well, one does. I've just gone through quickly with the handheld scope. And I've got signal going through the amp right up to the phase inverter. Going into the phase inverter. I don't have any signal coming out the phase inverter. So I've either made a wiring mistake somewhere, or that PCC85 is kaput. Remember, we don't know the history of these tubes, so yes, so we'll continue biasing it. Now I've just checked the bias on the current limiter with 180 watts of bulbs, and we're down to 37 milliamps now, which is much more respectable, but of course we're still going to go up. So we may find that we're going to have to go up again on the bias resistors, and I've got a feeling that we are. So now I've got a couple of 100 watts in there of bulbs. Let's just put another 40 in now. So I've got 193. So I've got 200 volts going into it now. And that's given me 300 volts. Let's just have a look what we've got now. Now I've got 22 volts going across there. So let's have a look. Actually, I did that plate to ground and not plate to cathode. So, in fact, we know where we are now. So, let's have a look. Can we get that to stay in there? 290 on there. That's the voltage we need. 280, not 290 volts. So we got a 22 volt drop divided by 500. It'll do roughly. That's 44 milliamps. Now remember, we've gone up on the bulb since I last tested it. So we'll times that by the 290. We'll worry about, and that's 12.76. So we need to go up again on the resistors. We're running those at just a shade over 100% now. Although I may over dissipate these tubes if I need to get the effective load resistance correct if I have to. Now I'm not, I'm not too worried if I run these tubes at 13 or 14 watts. They're cheap, plentiful, and they're no good for anything else. There's, you can't give the things away. So if we can make good use of them, that's the idea of this project. Can we make good use of these tubes? Right, we're up and running again, and I've just done the bias measurements, and we've got 9.6 watts now with a 680 ohm resistor, and we're still on the bulbs, but remember 5% for the screens, so that's going to be probably 9.3, something like that. So I'm going to go up again on the bulbs now, and I want to keep it on the bulbs for a bit, so I've run some protection. Now we're up to 220 volts now. We'll just put another one in there. So we're up to 230 volts now. I've got 349 volts on there, and that's kind of what I expected to have on there. Somewhere between 350 and 375. What I want to know is what's on those screens though, because we need to check quickly. 271. That'll do nicely. So that's okay. The top notch for those is 275, remember, on the data sheet. So 271 is under, so that's okay. And I expect that'll drop a tiny bit more once I get that tube conducting as well. So I'm now going to go across and check the bias again now at 230 volts. So now I've got 27.7, so that has gone up. 0.7 divided by 680, that's now 40 milliamps. Take away 5% for the screens is 38.8, and we times that by, let's get our cathode voltage there, plate to cathode, so we go in there, go there, 313 volts, 12.1. That's just about on the money. Oh dear, oh dear. That's pretty close. 12.1. Yes, that will go up a little bit once. I mean, we've got 232 now, just creeping up. Just flick the limiter off for a second, and that's dropped it up a little more, but not much more. So 235. 318 plate to cathode. So there's a good drop across those resistors. And the effective load resistance, according to my maths, comes out at 8.4, which is close enough. Really, that's close enough. 8.4. Little tiny bit over, but that's near enough. So that has actually worked with the 680 ohm resistors. That's right in the ballpark. And as I've said, we've still got one side of the phase inverter not conducting, so that will draw a little more current. That will bring the voltage down slightly, but not massively, but it will a little. 277. We're a bit over on the screens, but by a couple of volts over on the screens. So we've got that 10k resistor in there, so we could increase that slightly. I've only tacked that in. But yeah, that's looking good. So we've got it in a window. Sadly, we can't hear it running, and I've now got to go away and find out what I've done wrong. That plate on the it's the 82k resistor that's not conducting, and I'll while the meter's on there, I'll show you. So if I go there, so that's the feed side of the plate resistor. You can see there 275 now, so that's gone up quite high. We're going to have to check these tubes, see that we've not overvolted them. And you can hear there, we go on this side, 270. So again, it's virtually the same volts. Now if we go to the other plate resistor, 274, and we go to the other side, and you can see we've got 239 there. So there's a good healthy drop on there. I think the limiting value for that PCC85 is 250, so we're okay there. Let's just check the PCF80. So what we got going in there, 89 volts, so that's no problem. And oh dear, swearing at me again. What we got on the other side of that, 266. Wow, that's quite a drop. 89 volts. That's on the triode, but we got a healthy signal coming through it when I tested it on the scope. And if we try we've got 265 there, and if we look on that's the plate of the pentode, on the PCF80, and then if we look at the screen, we've got 125 on the screen. How much we got on there again? 168, 125, so that's okay. That's conducting nicely. Let's go back on the bulbs. So if we look here, you can see on let's just click the focus. You can see on the scope there, I've got that's the signal coming out of the plate of the PCF80. So you can see we've got and I've just got that strapped onto the base, base pot there, base capacitor there. So if we then go plate and out again there, and you can see now, we've got voltage now going peak to peak 13.5. so you can see now there's a massive chunk of gain there. Now if I go on to the grid stopper that I put on the phase inverter, we'll clip on there. You can see now on the phase inverter we've still got that signal there. Now if we come out of the phase inverter to the plate, through the plate and out onto the coupling cap, you can see we've got nil power. So that tells me where the fault is. So I've wired that up wrong because I'm a plank. It'll be something I've done, something stupid. Whew, right, so we're back. I've been working on this, trying to sort the problems out, and I just wired the phase inverter up wrong. I don't know what I was taking when I wired that up. Made a right mess of it, but we got there in the end, so that's the main thing. So that's all wired up. Looked at the bias again, and I've dropped the resistors down to 620 ohms. Because when I checked the bias, the effective load resistance I'd got was 8.9 when I brought it into here. So got those resistors in, and I've got the effective load resistance down to 8.4k, which is spot on for this amp. Now the bias is now set at 12 unbelievable, get this, these tubes, 12.3 watts and 12.4 watts. How about that? To say they were just randomly picked out. And these resistors are almost identical within an ohm. So yeah, so we've been very lucky with those. Still not wired up these, and I thought we'd have a look at these while we're doing some testing. But the other thing is the morph control doesn't work as well. So we've got to look at that. We're getting signal through, but I don't know whether it is as a pentode or a triode, because obviously that's what that control does. It morphs from one to the other. So we've got some work to do there to sort that out, but we'll worry about that later. The other thing we've got to do is the virtual center taps and the pilot light. Now, for some reason, whether I've got this muddled up, I don't know. I assumed they were 6.3 volts, but that's actually 13 volts that's on there. So I think we're going to have to fish these wires out and see what's on these wires again here. If we just look. So these wires here, I shrink tube them and put them in a just a cable holder there, just to keep them tidy and out of the way. So we're going to have to look at that. So still a few things to sort out, a few problems to do, but basically this runs now, and I have had the guitar through it. It's just not ever so loud at the minute, but we've still got the bypass caps to go on, and we've got obviously the morph control as well to sort out, so we may get some more gain when that's done. Right, more progress has been made. So we've now got the morph control running here. So that's working now. And everything is now working. But we need to get a virtual centre tap on this amp. So I've got one here that I've just... And we need to get rid of some of this noise. So if I go in here, you can hear that we've got rid of that humming now. And notice if we just put one on there, it's actually quieter than with both of them. So just turn that up. See that? So we could probably do with a hum balance pot for that. So now we've got this bias how I want it. I'm now dissipating these tubes at 13 watts, which is a watt over. And as I've said, I'm not concerned about the tubes because they're cheap and there's plenty about, so can't give them away. We've got the PCF 80 in at the moment. We're going to try the PCF 802 because that's got much more gain, but I don't think we'll need it. Right, so I've got 100 and 120 ohms now, and we're going to put those on and see. So the 100, you can see there, the 120. So if we put that on, now if we switch them round, and you can see the quieter at that. So yes, a hum balance pot would work very well for this. So that's pretty quiet. So we'll go 100 and 120, and that's the way we'll go with those. Right, there we go. So we've soldered in our virtual centre tap, which is here, and we've got the two resistors there for the pilot light, which is giving us about 5 volts, 5.5 volts maybe by tonight when things are hotting up or getting up towards 5.5. That's plenty for this amp. Like I say, it's not the brightest thing in the world, but it's not dull either, and it'll last. The bulb will last forever now. Right, we're just on the handheld for a minute. So this 10k resistor I've got here is 3 watts, and if we look up here, if I crank the amp flat out, you can see there that that's about 178 volts, and that's at 231 on the wall. So when that gets up to 240, there'll be a few more volts still on there. So I've done the maths on that, and that comes out at about, let me just see what that comes out at again. It was about 180 when I checked it earlier. Comes out at 3.24 watts, and that resistor is only 3 watts. And this is why, you know, you need to test these amps flat out on a scope, and that's where you're going to find problems. And you can see that resistor if we go down and look at it, and we just focus, there we go, you can see it's just beginning to go a bit tingy in the middle, a bit brown. Right, I've got the newer PRS that I've got plugged into this, and these pickups in this one just seem a bit more vicious than the others. So we started off, I've got this in triode mode. I got about number 4 on there. Well, what we'd say is number 4, something like that. Now I take the treble back a bit. Got that 200 picofarad on there. If you remember, we didn't have a 250, and if we turn the treble up, and that's harsh, so I think I might drop that to I think I'll get a 250 picofarad and increase that. It's okay as long as you don't turn it full. So the bass, it's not brilliant on it. So I usually have about half in there. The mid control. These pickups are already driving this amp. So take all the mid out. But if we take some, put some treble in with it, bass in. Always got that Marshall 100-watt plexi sound when you turn the mid right out of them. So that's where we are with that. And as soon as we turn this mid up, then we're backing off on here. We're getting nearer to the Fender sound. So that's with a full bass in, that's, and if we go full mid and full bass, now if we put it on the neck pickup, so that really that sound. Whoops. So again, half mid. If we go mid to 10 o'clock, you can hear it now needing a bit more treble. Unless of course you like that sound, then you don't need more treble. So let's start to add this morph control in then. So now we just go up, even that slight amount. See how fat the tone's getting there. Sounds awesome. So if we go up another notch on the morph control, if we go halfway now with the, just to drop the master down a bit, because you just see it now beginning to clip. If we go now to 3 o'clock with that, which is while it's upside down, now that sounds quite tasty. Now if we go full pentode, like you see, it is beginning to overdrive now. That doesn't sound too bad, but we back off the bass. In fact, we take all the bass out, but you can tell that, you know, the 47 nanofarads and the 0.1 on the PCF 80 there, so it's a very hard distortion. Let's take the mid out. So that's all the mid out. Now that don't sound too bad. Very Marshall-esque, that sound. Put all the bass in. Doesn't need it. again, that classic Marshall sound, you know, hardly any bass on there. Full mid. You can see now it doesn't sound so wonderful now, the overdrive. So if you take all the mid out, or most of it, and bring the treble up, if you drop the couple of caps to 22 nanofarad, that'd probably get a really good distortion from that. But that's still pretty good, as long as you don't overdo it with the mid out there. Now if we continue to go up with this volume here, so if we go up to halfway, we're up to about what would be number 6, and this thing is loud. And now it's getting into the territory. Dog, stop doing that, trying to bend a string, and you're nuzzling me with your nose. Let's try that in triode. Let's go the other way now. Let's put a bit more of the master volume in. Try it with pentode. Wow, that is loud, man. Single coil. See that when you turn that to triode mode, got the master full up now. Whoops. Beautiful clean tone. Right, I've just found some 10k resistors. That's a 10 watt, and you can see the difference is substantial there. So I'm going to drop him in, and all will be good. And then we are going to test that PCF 802. I bet you thought I'd forgotten, and I had, but then I suddenly remembered as I switched the camera off. Although I think that was a long enough demo. So here's a YouTube channel that I've been watching, and it's real old school tech, and really good. So give this channel a watch when you get a minute. Diabolical Artificer. It's got some good stuff on there, some interesting videos. Diabolical Artificer, have a watch. Right, I've got the PCF 802 in, which has a mu of 70. Now I've just been playing this amp on the 4x12. It's very bassy on here. On that other speaker it's really sweet, but very bassy. I'm expecting this to be incredibly loud, or a lot of gain, assuming that too works, of course. Whoa. I'll tell you what, if you changed all the coupling caps down to 22 and put a 22 in the bass for the bass cap, that would be a metal machine. Just you need to attenuate that grid though, going into that pentode. A little bit of compression going on there. When you pick the note, the grid on that pentode doesn't like it. My timing's off. Right, I've got the PCF 80 back in there, and to be honest, I think, you know, using that PCF 802, if you got this cranked up with that amount of gain, I guess it'd just be feeding back. But that's not why we designed this amp, is it? It's not, you know, that. I suppose that's a kind of added bonus. Hell of a lot quieter as well now. It's back in the case as well. It's even more quiet. Oh, now it's off the bench. You're not under the lights. But this is very basic on this cab. Seems to be a shade of compression when it's in that full triode mode. put any bass in. That's only half of it, to put it all in. The bass at 10 o'clock. We'll move a bit of a bit more of the pentode in. That's all the pentode in. Wow, that's no mid. We need to put the treble up. Yeah, it's a bit different on these speakers. That's all the mid. As soon as you put it on the neck pickup, it's very bassy. So with the PCF 802 in, you turn it on the triode mode and it is just too much for it. It just you're getting compression there. Not 100% sure why that is, whether it just wants a bigger grid stopper. It could probably do with a bigger grid stopper anyway on that, as I say, on that pentode grid. But you know, I haven't designed this amp for that sort of distortion, so I'm really not that bothered to go in there and change it, you know, unless I get problems when I've just got it clipping. But yeah, what a project. I've took the badge off the front as well. The badge was still on there. and it looked like someone had glued that on. There's a bit of glue on there, so yeah. So yes, I think it's the PCF 80 for me. I think if you're into playing heavy metal and stuff, as I was when I was younger, but I'm too rusty to play it now. I'd have to practice quite a bit to get that back. So that'll do it for this one. It's a bit of a long video this, and most of it's demos and things, so skip through some of the playing and stuff once you've had a good listen. So that'll do it for this one. So thanks for watching. You all take care, and I'll see you all in the next one. Bye bye for now.